We're working now to apply solving systems of linear inequalities. And this particular problem here is talking about whole number solutions. And really what that means is that sometimes it just doesn't make sense to deal with anything except a whole number, even though within our universe of solution or our solution set, there could be answers that are within that solution set that may not represent whole numbers. And so let me be specific and read this problem and get back to this whole number solution business. It says the theater club is selling shirts. They have only enough supplies to print 120 shirts. They will sell the sweatshirts for $22 and the t-shirts for $15 with a goal of at least $2,000 in sales. Now, if we're selling shirts, we're not going to sell 30.5 sweatshirts or 16.7 t-shirts. They're only going to be in whole numbers. We're not going to cut up a sweatshirt to get to 22.5. And so that's what we mean by whole number solutions. Now, taking this information about what this theater club wants to do, let's go. It says define the variables and write a system of inequalities to represent this situation. Well, I'm partial to X and Y. We could do S for sweatshirts, T for t-shirts as our variables if you wanted to. If you do, that's perfectly fine. I just don't like to have to write S's and T's. You know why I don't like to write S's? Because they look like a 5. Sometimes in my sloppy handwriting, an S I might later confuse for a 5. So I'm going to say that in defining the variables that X equals the sweatshirts, and Y equals the t-shirts. So now that I've got my variables defined, I can write a system of inequalities. So let's take this first statement. They only have enough supplies to print 120 shirts. Well, that would mean whatever combination of sweatshirts and t-shirts that we have, we'd have to say that X, the number of sweatshirts, plus the number of t-shirts, well, can't use equal, doing inequalities, has got to be, let's say, less than or equal to 120. I mean, it could be 120, right, if that happened to work out okay. So less than or equal to 120 t-shirts, total shirts. Now, let's deal with the second statement. They will sell the sweatshirts for $22 and the t-shirts for $15 with a goal of at least $2,000. So if X is the sweatshirt, then we got $22. This is the sales price of ever how many sweatshirts it is, plus $15 selling price for ever how many t-shirts we've got, and we want at least, that means a greater than or equal to $2,000. We'd be happy to make more than $2,000, I'm sure. Now, in order to graph these, which we're going to do on a TI-84 calculator, I kind of regret I did that last example on TI Inspire, but hey, it doesn't matter. I need to get this in some form of Y inequality statement. So in this first statement here, I'm going to subtract X from both sides, and when we do, we have Y is less than or equal to negative X plus 120. And then in the second statement, I'd have to subtract 22X from both sides and then divide everything by 15 to get Y by itself, but that would end up being Y is greater than or equal to negative 22 over 15x plus 2,000 over 15. which obviously both of those are divisible by 5. And I think that would end up being 400. This could actually be expressed as 400 over 3 if I reduce that, 2,000 over 15. All right, now I'm going to move over here to the TI-84 calculator. We're going to graph the system, and then we're going to look at what's a possible solution, and then specifically we're going to answer this question, is 45-30, and that would mean 45 sweatshirts and 30 t-shirts. Is that a possible solution? And in fact, I can really tell you right now that it's not, but we'll show it on the calculator. Because what's 45 sweatshirts plus 30 t-shirts? Well, we'll look at it on the calculator. All right, ready? Let's go. Okay, well, we're over here on the calculator. I want to graph these two inequalities, and one of those inequalities was y. Let me clear out what I've got here. Y is less than, let me see, before I do that, let me just, since I'm right here, there is an app on your computer that if you don't have it, you need it. I'm going to pull up the apps. And you can see here on my computer, on my calculator, it's option 7, inequalities. I've already got it active. I can open or close that app at any time. When I go into y equal, no, I don't have it open. Let me get it open. I'm going to choose option 7. Press any key to continue. All right, now I've got the app open. I can see here the x equal. I can see the quit app. All right. And what that's going to allow me to do, if I move this cursor here to the left, it highlights this whole thing. I hit enter, and I can change this from y equal to any number of inequality statements. And in this case, I want less than or equal to. And our first inequality there was then that y is going to be less than or equal to negative x plus 120. All right, and now I'm going to graph the second. I'm going to enter the second inequality. And again, I'm going to hit the left cursor to highlight twice, to highlight everything. And I'm going to hit enter. And if you recall, this time I need a greater than or equal to inequality. And now that I've got that, let's see, we had negative 22 over 3, 22 over, over 15, over 15x plus 400 over 3, or 2,000 over 15. Now, when I first go in here to graph this, I'm probably not going to see a thing because my window settings are not going to be correct. Well, I get a bunch of stuff, but I don't know what it is. And I'm going to first hit Zoom Fit. And I got a little bit of a picture coming somewhere, but it doesn't give me what I want. And I'm going to change the window settings again. So I'm going to go into Window. Now, first off, I can't have negative sweatshirts, which is my X variable. So I'm going to just set it to 0. And, I don't know how many shirts I could have. Well, I guess I could have up to 120 shirts, couldn't I? I mean, they could all be sweatshirts. So I'm going to change my X value to that. And I can't have negative number of t-shirts, so I'm going to set that to 0. And I could have up to 120 shirts. In other words, I could have 120 sweatshirts and 120 or 120 t-shirts. That'd be okay. And so let's, I guess I should probably change my scale to, let's change your scales to 10. In both the X and the Y scale. Now let's go look at our graph. I got a stat plot on. Let me get in here and turn that off. Get that out of the way. Didn't realize I had it on. Okay, now let's go back. All right, now we can see that the intersection of this graph then is where both the red and the blue overlap, and it's in this area right here. All right, and now we had one question is give us a possible solution. One way I could do that is I could go in here to trace, and it puts it, if you look at it, it puts it on one of the boundary lines. And so one possible solution is I could have 60 sweatshirts, that's X, and 60 t-shirts. I could go 60-60 on either one. And let's see, let's just move it around a little bit. I could have 60 sweatshirts and 45 t-shirts, somewhere in between there. And then I can just kind of move this around if I wanted to look at it. Let's say right here, get somewhere close to a whole number. I'll do it one more time. Okay. I could have, let's say, 50 sweatshirts and 58 t-shirts. And let's move that to the upper boundary. Or I could have 50 sweatshirts and 69 t-shirts, anywhere in there. Now, we were also asked a question, what about, could I have 45 sweatshirts and 30 t-shirts? And for there, I'm going to go in here and I'm going to ask for the calc button, which is second trace. And I'm going to say, okay, well, just give me a value here. Let's see, what is that inequality? Might take a look at that again in a moment. But I'm going to just choose this value. And I'm going to say, well, what about when X is 45? What's Y going to equal? Well, it would equal 75. And what if I just move that cursor down? Or it could equal 67. But if I move that down that vertical axis to say 30, well, that's not going to be in my solution set. So no, that is not a possible solution. Calculators are wonderful.